In this video, we'll take a look at a couple ways to summarize and visualize a list of data points. In particular, we're going to take a look at frequency distributions and also histograms. Okay, so let's take a look at this first example here. So we're going to construct a frequency distribution, which is a way of summarizing this list of data points by grouping them together into classes. So in the instructions here, it says to use 70 to 79 for the first class. So let's first list out all the classes. Right, so we want the first class to go from 70 to 79. And again, so these classes are meant to group the data points together according to how many of the values fall into each class. And so we want the since the lowest value here appears to be 75, we want our first class to be able to capture the lowest value, and we want the highest class to capture the biggest value, which seems to be 104. Okay, so we have our first class. We want to construct each of the classes after that so that they have the same width. Right, so here this goes from 70 to 79. So it looks like the classes are going by tens. So since the first class starts at 70, the next class should be 10 more, which starts at 80. And it should have the same range of values, right? So we'll go from 80 to 89. So these are called the class limits, right? So the class limits should always have the same width, right? So this is 70 to 79, 80 to 89, and then we just follow the pattern. So 90 to 99, and then 10 more goes from 100 to 109. And again, the highest value in the data is 104, and this class already captures that. So we should have enough classes to cover our data points. Okay, so now we want to count up the frequency, right? So the frequency should represent how many data points fall within each class. So the first class is the 70s, right? So 70 to 79. So we want to look through our list of data. Here it's not sorted at all. So we want to slowly go through the data and count up how many fall in, right? So we have 75. And then what else? We have 76, 79, and 75. Okay, so these appear to be the data values that fall into the 70s. So there are 4 of them. So the frequency is 4. Okay, so we want to repeat this procedure for the other classes. So now the second class is 80 to 89. So we want the numbers that are in the 80s. Right, so 82, 85, 85 again, 80, 89, 80, 88, 88, 88, 83, and 80. So these appear to be the ones that are in the 80s. So let's count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there are 11 of these. So now the next class is 90 to 99. So let's count them up. 93, 94, 96. So there appears to be 3 of them. And finally 100 to 109. So 1, 2, 3. So there appears to also be 3 of these. Okay, so those are the frequencies for each class. And in the end, to make sure that you don't miscount anything, right? So one way to check is that the sum of all the frequencies, so in this case 4 plus 11 plus 3 plus 3, so what is this? 15 plus 6 is 21. And we have 21 data points, so so it looks like we've counted the frequency properly. Okay, so that's the frequency distribution. So sometimes we'll want to represent the frequency distribution in a similar but slightly different way, which is called a relative frequency table. So instead of having the actual values for the frequency for each class, we replace it with what's called the relative frequency, which is the ratio of each individual frequency divided by the total of all data points, right? So basically this will allow us to represent which percentage of the data points fall within each class. So let's calculate that, right? So as a table, the classes are still the same, right? So let's write them in: 70 to 79. 80 to 89, 90 to 99, and then 100 to 109. Okay, so now how do I calculate the relative frequency? Right, so we take each individual frequency and divide it by the total. So that here the total is 21. Right, so the first calculation would be 4, which was the frequency for the first class, and then divided by 21. Okay, so let's calculate that. Okay, so 4 divided by 21 is equal to 0.1905. So let's round to 4 decimal places. And then we do a similar calculation for the other classes. Right, so we take each individual frequency for the class and divide by the total. So this second class would be 11 over 21. This would be 3 over 21, and this would be 3 over 21. And then again, we just calculate each of them. So 11 over 21 is 0.5238. And then 3 over 21 is 0.1429. And then this is the same calculation, so it's also 0.1429. Okay, so so these are the relative frequencies. And then sometimes it's better to represent these decimal numbers as percentages, right? So then we just times it by 100% to get the percentages. So let's construct the table. So the classes are the same. And now we'll type out the relative frequency, but as a percentage. Okay, so the classes are the same, so 70 to 79, then 80 to 89, then 90 to 99, then 100 to 109. And so multiplying by 100 is the same as just moving the decimal place to the right 2 places. So this would be 19.05%. This would be 52.38%. This would be 14.29%. and this should be also 14.29%. Okay, so those are the relative frequencies as percentages, and again, you can always check your calculation. So the total should be approximately 100%. So I say approximately because when we calculate these, we rounded the decimal places. So you might be off by by just a very small amount, but if you add these all up, it should be almost 100%. Okay, so sometimes the relative frequency table is useful for summarizing the data, because then we can see here about half the data is within this class here, about 20% of the data is within this class here, and so on, right? So summarizing the data is sometimes easier using a relative frequency table instead of the ordinary frequency table. Okay, so let's take a look at the next example. In example 3, we're given a frequency distribution that describes the age in years that a best actor has won an Oscar. And we have the age groups as being from 20 to 29 years old, 30 to 39 years old, and so on up to 70 to 79 years old. And the frequency distribution is given here. And so in this problem, we're asked to describe the distribution that's presented. So in terms of the sample size, that's the total of all the frequencies. Right, so we can just add that all up. 1 plus 26 plus 35 plus 13 plus 6 plus 1. And so in this case, there are 82 data points. So the sample size should be 82. How many classes or bins are there? That's just how many rows are on the table, right? So 1, 2, 3, 4, 5, 6. So there's 6 different classes. Okay, so now what about the class width, right? So the class width, so you shouldn't just take the upper limit and the lower limit, right? So what you should do is to see how to jump from one class to the next, right? So from here, from 20 to 30, this is plus 10. From 30 to 40, this is plus 10, right? So the class width is equal to 10. So what you should do is subtract like consecutive lower limits, right? So 30 minus 20 equals 10, and so on. So that's the calculation for the class width. Okay, so what about the class midpoints? So here now we use the upper and lower limits, right? So you just add them up and divide by 2, right? So so like for example the first one, so you have 20 plus 29 divided by 2. So here we need parentheses so that we can make sure the calculator follows the order of operations. So 20 plus 29 divided by 2 gives me 24.5. And then the next one would be 30 plus 39 divided by 2, which would be 34.5. And then the other calculations are similar, and we can sort of see the pattern going on here, right? So the class midpoints would be 24.5, 34.5, 44.5, 55.5, 65.5, whoops, 54.5, 64.5, and then finally 74.5. So following the symbol calculation here, but I'm going to skip them to save time. Okay, so then finally, what about the class boundaries? So you have to be careful here, right? So let's take a look at the class limits, right? So so the class limits say go from 20 to 29, then 30 to 39, then 40 to 49, then 50 to 59, and then so on, right? So the way we obtain the class boundaries is to look in between consecutive classes like this, right? So like say in between the first class and the second class, so midway between 29 and 30 would be 29.5, right? So so if I average together 29 and 30 divided by 2, the boundary would be 29.5. And following a similar calculation, you can see the boundary here would be 39.5. This would be 49.5, 59.5, and so on. And we also want a boundary at the very beginning, right? So if this pattern follows, the boundary before 20 would be 19.5. Okay, so what are the class boundaries? So let me write them here. Right, so it's 19.5, 29.5, 39.5, 49.5, 59.5, 69.5, and then the very last boundary could go after the 79, which would be 79.5. Okay, so these are the class boundaries. Okay, so these describes sort of the structure of the frequency distribution. So let's take a look at the next example. So in example 4, we're asked to construct a cumulative frequency distribution using the frequency distribution from example 3, which was this one here. So in a cumulative frequency distribution, what you do is you accumulate the classes one by one. So what do we mean by that? Right, so here the classes follow the classes from before, but they are set up slightly different. So the first class is still the same. So that would be 70 to 79. So this one is still the same, but the following classes are different, right? So all of them are going to start from the very beginning, which would be 70, and then they end up at the corresponding class here, right? So the second one would be both the first two classes put together, which would mean 70 to 89. Whoops, the first one was 20 to, I want to use the frequency distribution from 3, right? So this was 20 to 29. And then the second class combines the first two classes, so that'll be 20 to 39. And then the next one after that combines the first three classes, so that will be 20 to 49. And then we follow similarly, right? So you always start from the very beginning, and then you accumulate one more class. So 20 to 69, then the very last one would be 20 to 79, so containing everything. Right, so these are the classes, and then here we want the cumulative frequency. So the cumulative frequency should be how many fall into now these new ranges, right? So the 20 to 29 should still be the same as before, so there's 1. But the second class now is from the very beginning. It's the total of the first 2 classes, right? So that'll be 1 plus 26, which is 27. And then this third one should be the total of the first 3 classes, right? So you would add this plus this plus this, but we already added the first 2, right? So we can just use the previous number, which is 27, and add the new one, which is 35. So this would be 27 plus 35, which is equal to 62. And then here we've already added the first 3 together, which was 62. Right, but then we also have to include the 4th class, which would be 13. So this would be 75. And then the first 4 classes was 75. We add in the 5th class, which is 6. So this would be 81. And then the last one will be 81 plus the very last class, which is 1. And notice the very last one should be the same as the total, which we calculated previously. Okay, so this is how we construct the cumulative frequency distribution. Right, so you accumulate the classes one by one. Okay, so now we want to take this information and construct a histogram. So we're not going to do the cumulative histogram. We're just going to do the regular frequency histogram. So here the x-axis can be described in 2 ways, right? So the x-axis should be the values or the classes, right? The classes go on the x-axis, and the frequency should be the y-axis. And we can describe the classes in a couple of different ways, right? So if we're using class boundaries, that's these values constructed here. So starting from 19.5 all the way up to 79.5. And since we don't have a lot of space, we're going to skip. We're not going to start from 0. We're going to skip some values. And so sometimes it's customary to put this squiggly here to mean that you're skipping some values, right? So we're going to start from 19.5, and then the next one would be 29.5, 39.5, 49.5, 59.5, 69.5. Then I don't have enough space, so let's make this a little bit longer. And then 79.5. Okay, so the classes go on the horizontal axis, and the frequency goes on the vertical axis. Okay, so the highest frequency that we got in example 3 was 35. So maybe the frequency should go up by 10s up to, say, 40. And so now we just do a bar chart, basically, where the height of the bar is exactly the frequency, right? So the first frequency was 1. So here this should have a height of 1. And then the next one had a frequency of 26. So again, don't confuse the frequency with the cumulative frequency. Okay, so the next frequency was 26. So that's halfway between 20 and 30. So that's about here. and then we just repeat that, right? So let's put the number above the bar to represent how high it is. So 126, and then 35, 13, 6, and 1. So 35 is about here. And then 13, 6, and 1. So 13 is about here. 6 is about here. And 1 is about here. Okay, so so this is a histogram, and so sometimes we also want to draw the histogram using the class midpoint. So this would be exactly the same, except we label the x-axis slightly differently, right? So the class midpoint, so again we have to skip some values. So the first one was 24.5, then 34.5, then 44.5, then 54.5, 64.5, and then 74.5. So the frequencies are exactly the same, so 10, 20, 30, 40. And so because these are the midpoint of each class, right, so we should draw the bar so that the hash mark is in the middle of the bar. So here the first bar would be for 1. Let's make this a little bit shorter. All right, so that'll be like that. But then it's basically the same diagram, just the labeling on the x-axis is slightly different, right? So the next one is 26, so that's about here, and 35, so that's about here, and 13, so that's about here, then 6, so that's about here, and then 1, so that's about here. So this 1, 26, 35, 13, 6, and 1. And so by turning the frequency distribution, the ordinary frequency distribution, into this bar chart, that's a histogram, it allows us to visualize the shape of the data, right? So the horizontal axis represents the classes, and the vertical axis represents the frequencies. And so again, now we can describe the shapes of the distribution. And so there's some common shapes, right? So approximately normal, so that's the bell shape. So something like this would be considered approximately normal, right? So it should be symmetric about the middle. The height of the graph should be again around the middle, and symmetric on the left and the right, and it has this bell curve shape. So that's approximately normal. Uniform is when all the frequencies are about the same, so that it's flat, right? So this is this one would be considered the uniform shape. And in the two diagrams on the bottom here, you can see that it's not symmetrical, and the shape seems to have a tail on one side. Right, so here this has the tail on the left, and this diagram has a tail on the right. Right, so this extension on that where the data sort of spreads out on one side, that's called the tail of the distribution, and the tail indicates that the shape is skewed one way or another. Right, so the skew should be the direction of the tail. So this one would be skewed left, and a tail on the right would indicate that it's skewed right. So, I mean, there are distributions can have other shapes, but these are some of the common ones. So, with this in mind, we can go back to this previous problem, which asks whether the frequency, so this should actually say example 3, the frequency distribution here is this, does this seem to be approximately normal, right? So approximately normal should be symmetric like this, but if we look at this diagram here, you can see that on the right side the tail seems to be a little bit longer here. So it appears that this is skewed slightly to the right. So the shape in the histogram on problem 6 it appears to be slightly skewed to the right. Again, you can see here the tail on the right side is just slightly longer than the tail on the left side, so we can say that it's skewed to the right. Okay, so this was a discussion of frequency distributions and histograms, and again, it allows us to sort of summarize and visualize a set of data points, because when you have just a list of numbers, it's a little bit hard to get information from them, and so we want to visualize the data in this way.